Hi all. Now we are going to see what is sun tracking system and why do we need it. Basically the sun changes its position from morning to night. We all know that. And also from one season to another it also changes the amount of intensity or the light intensity. So a sun tracker is nothing but an apparatus that is used for orienting a solar PV panel, concentrating a solar reflector or lens towards the sun. Solar panels require a high degree of accuracy to ensure that the concentrated sunlight is directed precisely to the PV device. So the sun tracking systems can substantially improve the amount of power produced by a system by enhancing morning and afternoon performance. Means like either by morning or in the full session or any way you can improve the performance of the PV system by a solar tracking system. Strong afternoon or means when you have a very heavy sunlight, so the performance is particularly desirable for a grid tied PV systems. So because this is because the production at this time will match the peak power demand period for the summer season. A fixed system oriented to optimize this limited time performance will have a relatively low annual production. This is because the PV panels are fixed and they do not move to track the suns. Means like you know if it is exactly fixed, we won't have anything movable. We would have seen in my previous video that like there are different types of solar panels. It can be fixed, um, you know it can be of mounting, how to mount, adjustable or tracking and all. So here if the same concept is applied, no actually concentrated, if it is exactly fixed you cannot get an optimized performance and it might be limited, not the exact desirable range. So for low temperature solar thermal applications, the trackers are not generally or usually used. This is very simple. This is because tracking systems are more expensive when compared to the cost of adding some more extra collectors, PV collectors. In addition, more restricted solar angles are required for winter performance, which influences the average year-round system capacity. For solar electric applications, trackers can be relatively inexpensive when compared to the cost of a PV system. This makes them very effective for PV systems in high efficiency panels. From the maintenance point of view, we have to think that the solar trackers need to be inspected and lubricated on an annual or seasonal basis. Like seasonal, of course you can obviously understand, when the winter is there, even if it is a monsoon period we have to take care of it, or even if it is a winter we have to maintain, we have to have a proper maintenance after the monsoon or after the winter. And likewise for the summer, we have to just properly lubricate everything. So we'll move on to the structure of the solar tracking system. This is very simple sun tracking system, and which is having two photodiodes, and this is just showing how the light intensity is falling and the angle of light and been using the two diodes. I hope you can see this. Yeah. So there are several techniques to track the position of the sun and adjust the position of the panel. And most common tracking sun tracking system is to use the relationship between the angle of light source and the differential current generated in two closed photodiodes due to the shadow produced by a cover over them. So this is the basic common technique. The structure of the sun tracking system based on the relationship between the angle of light and the differential current, as I said, in two photodiodes is see, it's just shown in this figure. So the shadow over the photodiodes will be generated by the cover when the light sources misalign, if it is not properly aligned. So as a result, one diode is more illuminated than there. So there will be differential, illumination, and difference of current will be there. So this the difference between the generated current becomes larger as the misalignment. So if it is not properly aligned, obviously the current generated by two photodiodes will be different, and the larger the difference, uh, that's because of the misalignment, increases much further. So the system can use this difference between these two currents to orientate the system to directly, face the sun. So you can check based on the difference in current. This tells them, as I mentioned repeatedly, it's about the increase in the misalignment. So if in case it has been properly used, then obviously we can say that we can just reduce the misalignment. And if or the other way of saying, in other words, if the difference in current is reduced, then obviously it represents the misalignment being reduced, or I can say the orientation of the sun is directly with the two diodes. So the sensor is composed of two modules for the X and Y axis as shown in figure. So the two diodes, metallic connections, resistors, all these protectors, I'll show it in the other one. See here, metallic connection, resistor connections, and a cover are the other components of the sensor module. So it has to sense it. We have obviously have to have a sensor. We should have a feedback, right? So based on which the tracking has to be, or the movement of the position of the alignment or of the panel should be there. So this is the top view of the sensor's x-axis and y-axis modules, and dynamic range is the parameter that the sun tracking system responds to the threshold limits. The distance between both modules does not have to limit the dynamic range. That's very important. If the dynamic range is of course increased, the sensitivity of the current differences decreases. Therefore, the dynamic range and the sensitivity, there is a trade-off between them. Okay. As a solution, two parallel sensors can be operated to reach the desired sensitivity and a high dynamic range is in an optimal manner. Currents generated by these two sensors depend on the illuminated area. If one diode is more illuminated than the other, the currents generated by each photodiodes become different. If the sensor is positioned with a predefined angle with respect to the source of light, this will yield different currents generated in both photodiodes as shown in the figure. So in this way, the misalignment of the system is calculated. This is how we try to calculate. The system uses this differential signal to orientate the panel to the light source. There is a gap, of course, between the two photodiodes, and this is necessary to avoid the combination of carriers. So the illuminated area of every photodiode can be calculated by this formula, where all these parameters are given. What is WA? It is nothing but the width of the aperture of the cover. WG is the gap between the photodiodes, H being the width of the sensor, and theta is the misalignment angle, L being the depth of the sensor. Now, so the difference between the two currents is this. This is how it is represented, and so the theta, the misalignment, can be calculated by this way. And so if we try to summarize this two currents, the variable can be normalized and the dependence can be omitted. And so further, again, by this we can even try to formulate or regulate the theta, which is nothing but the misalignment angle. And finally, we conclude this theta being tan inverse of WA minus WG by 2H. So this tells you how the misalignment is. Fine. Hope you can understand. Now, this is very important. This is the simple flow or basic block diagram representation of how a sun tracking system is used. So we have a bias circuit. This is a simple block diagram with a sensor output with a motor control of movement of the PV panel. So differential circuit and adder circuit we have seen in the equation, and we have a controller, microcontroller, which with the sensors input. Based on that, it has based on the sensor's input and the program being given fed the motor's position. We have the motors which actually changes the position of the PV panel. So we have the relays and the power supply for actuating it. So the different signal data is compared. Before moving on to that, let us have a small understanding that the solar sensor output should be conditioned to adapt the sensor output to the microcontroller voltage range. fine. And the controller produces the inverse bias of photodiodes to orientate the panels, which is actually used to minimize the current difference. Usually for control purposes, current signals should be converted to voltage signals. So this is a simple flow diagram represented here, and by for implementation of theta equation, we have seen the misalignment equation. The sensor outputs are added and subtracted by the differentiator and the adder circuits here. That's what I told you. So the reference angle theta is obtained by the microcontroller, while actual motor positions are fed back to the microcontroller. The reference motor positions are achieved by the control signals to the motor drive. So the different signal are compared with the maximum threshold. If the value is higher, so obviously the sun is misaligned more than the selected angle. Hence the reverse action should be taken by the microcontroller that controls the drive, motor drive. Sometimes the movement of not only the sun but also the clouds can affect the output. So the presence of cloud may cause the microcontroller to misinterpret the moving direction of the sun. This results in moving the platform in a wrong direction and consuming unnecessary output energy. These malfunctions can be eliminated by using intelligent control techniques. So let us see the sun tracking algorithm. So an algorithm is required to for the determination of the sun's search the sun or the sun tracking. So sun tracking is the normal operation, while sun searching is required during the presence of clouds. So sun tracking is slightly different from searching the sun or sun searching. The flow diagram or the flow chart is shown here for the sun tracking algorithm. The microcontroller is initialized to access the previously recorded data table to decide to run the sun search, sun tracking or cloud algorithms. The radiation data table has the information for a typical cloudless day, and the radiation calculated from these data, predetermined data, is used to determine whether a cloud has passed over the sensor, if it is there, or it is passed over whatever it is that has been calculated by this data. The stored information makes it possible to reproduce the system movement in case of clouds. So this is generally for the clouds also. Mainly the sun searching or the sun tracking states are a function of the radiation. The system will work in the sun tracking state under good meteorological conditions. This state is in charge of storing the information of the tracking movement. The system movement can be provided by the microcontroller that provides appropriate switching signals to the motor drive in order to reach the reference motor positions. The sun searching or sun tracking states are a function of the radiation. So this will work in the sun tracking state under good meteorological conditions. If a cloud is detected, the corresponding state will be the cloud algorithm. Then the movement can be replicated by the stored information in the sun tracking state. The system remains in the state until the radiation returns to another value. The cloud is expected to last for about 15 minutes, 12 to 15 minutes or 10 to 15 minutes. When this time is over, the system will look for the sun and the maximum radiation. This temporal limitation is used to minimize the error due to the approximation. So the sun's movement is now characterized by azimuth and elevation angles. Depending on the time of day, the elevation angle changes in a different way. For an example, the early morning, the elevation angle changes steeply and the angle almost remains constant. Yeah. Whereas the main state selection is based on the addition voltage being added. We have seen in the previous part also, flow chart also, because radiation is calculated from these data. Once the state is selected, which state is supposed to be selected, that is done. The fundamental variable is the differential voltage. These data are sampled to know the sun's movement in the sun tracking state, and so the sun search state is in charge of orienting the sensor towards the sun if partial sunlight is available due to clouds. Thank you.